Good afternoon. I would like to first off thank you for taking the time to attend today's presentation. My name is Lance Zurich, and I'm the product manager for the Fischer-Technic Education Division over here at Studica. And today, as you can kind of figure out, I'm going to provide you with an overview of Fischer-Technic's line of pre-assembled industrial simulation and training models. Now, whether you're an educator at the high school level involved in, let's say you're involved in CTE training, or if you're a college professor, or even an industrial trainer teaching programming skills that are required in manufacturing, in any of these cases, I think, or even if you're, let's say, someone who's looking for ways to make IoT related concepts easier to understand to employees or customers, in any of these cases, I think this presentation is going to offer you a lot of good material coming up. And the first thing we're going to start off with is by considering the skills gap. Now, if you've had the opportunity to attend any of our other Fischer-Technic education webinars, you probably heard me discuss the importance of STEM education. And of course, STEM is the acronym that stands for science, technology, engineering, and mathematics. And at this point, it really should go without saying that STEM education is probably the most discussed topic in education over the last decade. Now, as most of us are aware, the push for developing STEM skills in students is really in large part to help best prepare them to take their place in the modern workforce. Not so long ago, when our parents or even our grandparents were entering the workforce, employers in areas such as manufacturing, like you see in the photo, might have been satisfied with hiring workers who could demonstrate good motor skills and a solid work ethic. But as manufacturing, of course, has become more and more dependent upon automated processes and robotic control, because of this, employers now desperately need individuals who have a background in areas such as mechatronics, industrial electricity, mechanical components, and programming PLCs. And I will mention, we were just at a conference in Detroit last week, the Automation Conference, and this was a topic that came up over and over again, how much these companies that are involved in manufacturing just cannot access the workforce that's needed to control and program the machines that need to be used at this point. But anyways, as it ties in directly with the solutions we're going to be looking at this presentation, let's consider that last skill area that I touched upon before, which was being a PLC programmer. Now, first off, for anyone who may not be familiar, a PLC, or I should say the term PLC is again an acronym just like STEM is, but in this case, the letters stand for Programmable Logic Controller. And essentially, a PLC, or a programmable logic controller, is a very specialized computer that's used to control the types of machines and automated processes that are typically found in an industrial setting today. And these are going to be things like, let's say, how a manufacturing plant is automated. Now, as the world of manufacturing becomes increasingly dependent upon these types of automated control systems, of course, the need for workers skilled in the programming of such systems grows exponentially. So how much can a PLC programmer earn? Well, just to give you an idea of how highly prized these programming skills are, here are some salary figures for PLC programmers as quoted from job search website nuvu.com. Quote, the average PLC programmer salary in the USA is $78,000 per year or $40 per hour. Entry-level positions start at $43,924 per year, while most experienced workers make up to $132,600 per year, end quote. Now, as I prepared the original version of this webinar, I took a look at the then current job openings for PLC programmers on the Nuvu website. This would have been back in February of 2020, just being pre-pandemic. The listings at that time showed 15 open positions being advertised with salaries of over $75,000 per year, and two of which even listed salaries of $195,000 per year. Now, I'm going through an update of this of the webinar, and I looked into the salaries, and essentially everything is remaining in tune with this. So this is not something that's really changed since the pandemic. The figures are the same. And so basically, because of this kind of trend that's going on, you see a lot more students enrolling in PLC training programs at the college and university level. And at the same time as you have this, what you could call the workforce of tomorrow, is they're seeking their training. You also have more and more manufacturing companies, like I mentioned before, who are facing an urgent need right now, who are enrolling their incumbent workers into private training schools offering programs on things just like this. So with that all being said, how long does it take to learn these skills? Well, depending on a student's background and experience, very basic PLC programming skills could be learned in as little as 30 to 40 hours of training. But of course, to be really proficient in all five of the most widely used PLC programming languages, which you see listed on the screen now, as well as really learning how to efficiently troubleshoot and address errors and equipment breakdowns, of course, more training would be required. Now, once again, while many students can learn PLC programming skills in a college lab setting, there are, of course, other options available. Again, there's the high school CTE, career and technical education programs, adult continuing ed programs, vocational training, technical training schools and trade schools, and of course, employer-sponsored work incumbent worker training programs. Now, that all being said, the question that still arises for the educator, whichever of those hats you wear, whichever of those classrooms you're in, is how do you teach PLC programming in a way that makes it engaging and relevant to the student, whatever the background? How do you get away from the dryness of textbooks and video presentations, which we've all gotten very used to at this point, and instead make it more realistic and hands-on? But there are other areas of focus beyond just programming that need solutions for demonstrating, exploring, and understanding different aspects of automation and control systems. Now, it could be, for example, that let's say a company is involved in creating or marketing a new type of software-based solution, and they're looking for ways to make more tangible processes, which might otherwise be perceived as too abstract, or to test it out in a more realistic fashion. You could be talking about a manufacturing company that's looking for a way to better visualize the production process for workers or stakeholders as they prepare to build a new factory. Or even you could have something like a company that's looking for an engaging way to demonstrate their services or solutions in a public setting, like a trade show, like I was talking about before. Now, in each of these cases, and of course there's more, there is a need for finding a solution that is engaging, which can effectively mimic and simulate real-world automated systems. And that brings us to the line of fischertechnik industrial simulation and training models. Now, these models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line consists of a series of pre-assembled small-scale models which are designed to replicate in both appearance and in function various automated robotic machines and systems which you would commonly find in commercial manufacturing. Now, before we get started, though, this of course begs the question, so what is fischertechnik? Well, just to provide you with a little bit of background, fischertechnik has been creating tools for teaching students of all ages how technology works for over 50 years, all based around their unique building system. Now, what makes this system unique is that unlike many other popular construction systems where the components are designed to simply stack, in the fischertechnik system was created with more of an engineering mindset. The core block in the fischertechnik system is designed to enable attachment from all 6 sides, and because of this, it allows for almost limitless design possibilities. Now, this coupled with the many parts that are designed for very specific functions and the way that things together are slide together and lock in place using a tongue and groove assembly method allows you to address very specific design needs. The original fischertechnik system was created back in the 1960s by German inventor Arthur Fischer, who besides fischertechnik is noted for countless innovations used in both the construction and the automotive industries. Now, Mr. Fischer, at the time of his death back in 2016, had already held more patents in his name than Thomas Alva Edison had amassed during his own lifetime, just to give you a comparison there. Now, besides fischertechnik, Mr. Fischer was also the inventor of synchronized flash photography, and that was back in 1949. And he's also known as the creator of the expanding nylon wall plug, which is often used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fischer Group, still employs thousands of individuals worldwide, producing many variations of fastening devices which are used in building construction. And they also produce numerous components used in automobile assembly, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of the fischertechnik sets, and that's whether we're talking about the sets that are for retail sales, for home use, or those that are for classroom use. In any case, the focus has always been on helping to foster an understanding of technology and how things works. how things work, I should say. Many of the products offered by fischertechnik for the education sector, what we would call subject-specific sets, for example, focusing on different STEM-related areas, things like mechanics, pneumatics, robotics, or renewable energy. Now, in many of these sets, students are asked to build a progression of models using the unique fischertechnik system, and then they're asked to perform various experiments, which allow them to explore and understand different aspects of that subject. And there are also sets that are designed to enable schools to offer a complete standards-focused curriculum-based program where the focus is on project-based learning. Now, these sets are, again, this is the main end of fischertechnik, and it's what a lot of people know it for. But the line of fischertechnik simulation solutions, which are, of course, the focus of today's presentation, are something much different. The line consists not of kits, but again, of a series of pre-assembled small-scale models which replicate in appearance and function various automated robotic machines and systems. Now, some of the types of models that you'll find in the fischertechnik simulation line include things like conveyor belts, punching machines, 3-axis pick-and-place robots, color sorting lines, and even high bay warehouse storage systems. Now, besides just these individual models which focus on specific automated processes, fischertechnik also offers what they call an integrated factory simulation model. And this model consists of 4 individual workstations. In this case, it'll be a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with an oven, and a sorting line with color detection, which are designed to work together as one self-contained material cycle. And of course, we're going to be looking at that in a little bit. Now, before we look at the models in more detail, let me very briefly outline some of the advantages of using the fischertechnik simulation solutions. Now, I will apologize in advance, as a few of these are points that I've already made before, but in each case, I think it's well worth repeating. First off, fischertechnik simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. And this could be, again, for understanding how automated systems work, or for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. Next, the models are also designed to realistically replicate in both appearance and in function common automated systems, things such as conveyor belts, sorting machines, robotic arms, and more. Now, because the models are compact and in most cases tabletop size, they're not only ideal for use in the classroom or in-office demonstrations, but also for demonstrating software or other technology-based offerings in a trade show environment. Next, quality. Each fischertechnik simulation model is a hand-assembled, high-quality, German-made product. Each of the models you're going to see is available in a 24-volt version designed for use with industry-standard PLCs. Now, it doesn't matter whether you use Allen Bradley controllers, if you prefer Siemens controllers, or if you use controllers from manufacturers like Honeywell, Mitsubishi, General Electric, what have you. It doesn't matter. You can use your PLCs and to control the 24-volt version. So whichever PLC you're most familiar with, that you prefer, you can use that. Likewise, just as you can use your choice of controller, you can also use your preferred programming language from the list you see on here. The one thing I will mention is that in most of the cases with the 24-volt models, no PLC is included. And in most cases, again, all programming and any programming guidance, as well as any power sources or hardware or additional materials, are going to be the responsibility of the end user. So in most cases, you're talking about the model itself, and if there's going to be connections that need to be made and what have you to a PLC connection board or to the PLC itself, et cetera, those are things you're going to be responsible for. There will be a couple exceptions, and I will mention those before the end of the presentation, but for most of the what we're going to be looking at, keep that in mind. Now, in addition, for non-industrial users and for those educators who are not versed in or involved in teaching PLC programming, there are also several models which are currently available in 9-volt variations. Now, in the case of these 9-volt versions, they will ship pre-wired to fischertechnik's own proprietary robotic controllers, which are known as the fischertechnik TXT controllers. And each of these controllers will be pre-programmed using fischertechnik's own RoboPro graphic programming software. Now, in most cases, the only additional component required with these 9-volt models will be the addition of one or more 120-volt power adapters, which we will specify as we talk about each model. Otherwise, in most cases, these models, these 9-volt models, should essentially be ready to use out of the box. Continuing with our advantages. Now, if you're involved in demonstrating or exploring IoT, also known as the Internet of Things, besides the fact that many end users have adapted some of the models in the primary line of simulation and training models for IoT purposes, fischertechnik now also offers a special IoT-focused version of the factory simulation, which is designed specifically for exploring and understanding cloud-based control and what is sometimes referred to as Factory 4.0. Now, in this instance, the model is designed to be both controlled and monitored from a special web-based dashboard. And of course, we're going to look at this model in more detail a little bit later in the presentation. Finally, fischertechnik simulation models are cost-effective. Now, if you've had the opportunity to look into any of the other hardware-based industrial simulation options that are available in the marketplace, you'll, of course, probably notice pretty quickly that the entry point for these products can easily be $20,000 to $30,000, $40,000, $80,000, even much more. fischertechnik simulation solutions, on the other hand, are available just a fraction of that price, as well as, again, being compact, and that's a big point. Realistic, high-quality learning and demonstration tools. So with all that being said, let's begin our look at the models. First model we're going to look at is the vacuum gripper robot. Now, what you're going to see in this video is a vacuum gripper robot, which is a 3-axis robotic model with a vacuum gripping device. The model you're going to see is designed to work to precisely pick up and position workpieces in 3-dimensional space. The model includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, which is the blue brick component you see in the video, and a solenoid valve. The dimensions for this model are approximately 9 by 19 by 15 inches, and it has a weight of just about 7 pounds. Now, the 24-volt version of this model, as well as all of the first 5 24-volt models that we're going to look at today, each have a relay board for motor polarity reversal, and both the multi-pin connector, that being 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. Again, this 24-volt version of the model, as well as all 24-volt versions that we're going to talk about, with 1 or 2 exceptions, will require you to provide the PLC and the program. I will also mention that for this and all of the other models we're going to look at today, the specs are also detailed in the product listings found on the Studica website, as well as the fischertechnik.biz website. And if you do need to have any of this in a PDF format, you will get my email address at the end, and you can just feel free to contact me, and I will get you any of that information you may need. We'll let that play out for a second. And safely down. Moving right along, we're next going to look at the automated high bay warehouse. Now, this model features a transfer station with a conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays, along with 9 individual storage spots. Components on this model include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, along with a selection of different colored workpieces and carrier trays for each. I will mention that this particular model is a favorite among educators that I've worked with who teach programming. And the reason for that is because it gives them so much to work with. Obviously, all of the different tray spaces that the arm has to move in and out of very precisely, and all the different movements that have to be programmed in. So you have a lot of precision to work with, and you have a lot of different details to work with that requires, very specific coding. So again, if you're teaching programming, this is an ideal model to work with. Gives the students a lot of meat to deal with. The dimensions for the model are approximately 19 by 28.5 by 15 inches and has a weight of approximately 18 pounds. Again, the 24-volt version has a motor or a relay board for motor polarity reversal and both a multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. And again, you do need to provide your own PLC and programming, and there is a 9-volt version of this available if you are interested in that. The next model we're going to look at is the multi-processing station with oven simulation. And the model you're going to see here features a furnace simulation with a pneumatic sliding door. There's a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components found in this model include 4 mini motors, 6 push button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for the model are approximately 20 by 14 by 12 inches, and it has a weight of just about 11 pounds. Again, the standard 24-volt version for use with PLC of your choice will once again have a relay board for motor polarity reversal, and both the multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And there is a limited edition 9-volt version, which in this case is connected to 2 robotics TXT controllers and will require 2 120-volt power adapters as well. We'll let this finish up. And there we go. The next line in our model in our progression is the sorting line with color detection. Oh, hang on a second here. There we go. Up. Sorry. Now we can go. All right. This simulation features a system for detecting work pieces of different colors, and it sorts them via conveyor belt into 3 different storage bins. Components on this model include, oh, hang on a second here, we got ahead. No wonder. I'm having a problem here with this. Okay, this we got to mute. This we got to go. Let's try this again. Okay, what you're going to see here is the sorting line with color detection. And this simulation features a system for detecting work pieces of different colors and sorts them via conveyor belt into 3 different storage bins. Now, the components you're going to see on this model include 2 mini motors, 5 photo transistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for the model are approximately 20 by 14 by 12 inches, and it has a weight of just about 10 pounds. Now, as with the models that we looked at before, the standard 24-volt version, again, has the relay board for motor polarity reversal and both the multi-pin connector, again, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And again, you do need to provide the PLC and the programming of this. And there is a 9-volt version that's still available. It comes pre-wired to the robotics TXT controller and would require one 120-volt power adapter with that. And now that we've got that all sorted out, we're going to talk about the factory simulation. And this is basically combines the 4 models that we've just reviewed. Again, the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with the oven, and the sorting line with color detection, combines them all into one self-contained material cycle. And now we can begin to watch this video, and the cycle that you're going to see is going to work like this. Work pieces are going to be retrieved from the automated high bay warehouse using the vacuum gripper robot, and then they get moved to the multi-processing station with the oven to be worked on. And after the work piece has been processed by that station, it's then sorted by color in the sorting line with color detection before again being moved by the vacuum gripper robot back to the automated high bay warehouse for storage again. Now, as we've already discussed the components of each model previously, I'm not going to belabor it by restating them here. But what I do want to discuss are the dimensions of this model as a whole, as it once again combines 4 individual models into one cycle. It does have a much larger footprint of approximately 39 by 31 by 16 inches, and it has a total weight of between 43 and 46 pounds, and depending on whether we're talking about the version using the pre-programmed TXT controllers, or if we're talking about the version that's for use with PLC. Now, due to these dimensions, please note that this model can only be shipped flat as freight on a pallet. That's when we ship it out. Same thing when if you as the end user need to ship it somewhere for use, you always want to ship this flat, always has to be shipped on a pallet. I also want to point out that as the factory simulation models, and this goes for any of the factory simulation models we're going to be looking at, is there's a couple IoT versions a little later. These all tend to be in very high demand, so please anticipate a possible turnaround of up to 3 weeks prior to any orders for these models leaving our warehouse, just because they can be, again, they're in very high demand. A few things to note, of course, it's available in the standard 24-volt version, and in very limited quantities, it is available in the 9-volt version. The 9-volt version is wired to 5 robotics TXT controllers, and because of this, it's going to require 3 120-volt power adapters because of the way they're daisy-chained. And again, it's the same thing as I mentioned with the connection boards before. You have a multi-pin connector, 34 pins with a grid of 2.54 millimeters for the 24-volt version, as well as additional PCB terminals for pushing connections for inputs and outputs, and of course, the PLC and the programming has to be provided by you. Now, before we move into the next group of models, I do want to mention that there is a storage option available. As I touched on before, you want to store or transport your factory simulation models flat. It's also good to protect them by getting the travel and storage case. The travel case itself consists of an aluminum pacemaker profile with plastic plates and steel ball quarters, as well as 4 steel tilt handles and angle protection corners. The upper section of the case is partially lined with soft foam blocks in different heights to help cushion the model, and it also has 3 internal zipper pockets for storing the cables and other extra accessories, such as the work pieces and different things like that that are included with the model. The lower portion is lined with hard foam, and it's designed so that once the top of the travel case is taken off, the model can remain in the bottom section of the case and be fully functional. The case itself has exterior dimensions of approximately 41 by 33 by 17 inches, and it has a weight on its own of approximately 53 pounds. So if you put a factory model in there, figure that depending on which version of the factory you're dealing with, you're probably talking about 100 to 115, 120 pounds total weight for that altogether. Again, even when using this travel case, we still insist that these models should be shipped flat and on a pallet whenever possible. Going back to our models, the next model is a basic conveyor belt. And this is a transport belt that has a length of approximately 275 millimeters that is used to transport work pieces with a diameter of up to 29 millimeters. Multiple conveyor belts can be easily connected to increase the length of transport as desired. Now, components on this model include an excess motor, a push-button limit switch, 2 phototransistors, and 2 LED light barriers. The dimensions are approximately 14 by 10 by 4 inches, and it has a weight of just under 2 pounds. And as before, the standard 24-volt variation does include a multi-pin connector, but this time it's a little different. It's a 26-pin connector with a 2.54 millimeter grid is shown here. And there is also, for a limited time, a 9-volt version. It comes pre-wired to the robotics TXT controller as shown here, which does require one 120-volt power adapter for operation. The next model is a variation of the conveyor belt, but it includes a punching machine. And this is essentially, again, the same conveyor we just looked at, except this time with a machining station built onto it. Components on the model include 2 excess motors, 2 push-button limit switches, 2 phototransistors, and 2 LED light barriers. The dimensions are 15 by 12 by 7.5 inches. It has a weight of about 3.5 pounds. Again, the 24-volt version is the standard version. This one, again, has the 26-pin connector, 2.54 millimeter grid as shown here. And in this version, there is still a 9-volt version available. Has 1 TXT controller wired to it, does require one 120-volt power adapter. Next up is the indexed line with two machining stations. And this model features a U-shaped conveyor line consisting of a milling and a drilling station and four conveyor belt sections. Components on this model, besides the four conveyor belts, include 8 XS motors, 4 push-button limit switches, 5 phototransistors, and 5 LED light barriers. It has dimensions of approximately 19 by 18 by 11 inches, and it has a weight of just about 8 pounds. Again, it's available in both the standard 24-volt version, in this case, again, with a 26-pin connector and 2.54 millimeter grid for your PLCs, and in a limited release 9-volt version wired to the pre-programmed robotics TXT controllers. And this requires, this one does require two 120-volt power adapters. The next variation is the idea of a pick-and-place robot, which is known as the 3D or 3-axis robot. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the workpieces it picks up in three-dimensional space. The degrees of freedom for this robot are as follows. Axis 1 will turn 180 degrees. Axis 2 can move forward or backwards 90 millimeters, and Axis 3 can raise or lower 150 millimeters. Components on this model include 2 XS motors, 2 encoder motors, and 4 push-button limit switches. Has dimensions of approximately 19 by 16 by 9 inches and a weight of just about 6 pounds. Again, it comes in either the standard 24-volt version with the 26-pin connector and 2.54 millimeter grid, as is shown here. And it does come in a 9-volt version as well, but in this case, this is not a limited availability model. This is the standard model, which once again comes pre-wired to a pre-programmed robotics TXT controller and requires one 120-volt power adapter. So that essentially concludes our look at the first 9 variations of simulation models. The next grouping of simulation models focuses specifically on the area of IoT and are designed specifically for demonstrating and teaching about cloud-based monitoring and control. Now, these models go by the name of Training Factory Industry 4.0, and they are available in both 24-volt version, again for use with PLC, and also a 9-volt version for classroom and demonstration purposes. Now, these have been designed to help address how the recent changes in industrial production, which are, of course, driven by digitization, have created a need for stronger networking and more relevant information on all the production levels. Now, with this Industry 4.0 update of the existing factory simulation model, such digitization activities can be simulated, learned, and applied on a small scale before you implement them on a larger scale. Now, as the following video showcasing the 24-volt version provides a really nicely narrated overview of how the factory works, I'm going to step back for a moment and allow you to watch and listen to the narrator. Hmm. So that all being said, let's just provide a little summary of some of the things that were discussed there. The following topics can be addressed with the Fisher Technic Training Factory Industry 4.0. You can address training and simulation on a realistic production model, in-depth learning via haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production in lot size 1, integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance, the linking of production and materials planning data, and the connection of upstream and downstream logistics processes. I'm learning how to speak today, excuse me. Now, as you just saw, the model incorporates many features not found in models we've previously discussed, besides just most notably being the use of the cloud-based dashboard for monitoring and controlling the model. Some other examples would be the camera attachment that's used for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. Now, the use of NFC chips in each individual workpiece, each of which has a unique identification number, enables the position of each workpiece on the material in the work cycle to be mapped. And the use of MQTT, or message queuing telemetry transport, allows the networked TXT controllers to communicate with one another. Now, as there are two variations of the model, let's talk about a couple of the differences aside from the voltage requirements. And we're going to begin by focusing on the 24-volt version and what makes it unique. First off, it is a bit of a hybrid in that while requiring a PLC for all operations and control, it does actually incorporate one Fischer Technic Robotics TXT controller. And in this case, again, as it was mentioned in the video, the TXT controller acts as the MQTT broker and interface to the Fischer Technic cloud. Communication between the PLC and the TXT controller is carried out via an IoT gateway via OPC UA. OPC UA, which is also known as OPC Unified Architecture, is the standard for exchanging data across different platforms, just like this. Now, in addition to the TXT controller that's used here, there's also an IoT gateway using Raspberry Pi with Node-RED. And this allows the option for not only presenting and using data on a dashboard in the Fischer Technic cloud, but also being able to display data and calibrate the stations of the factory in a Node-RED dashboard. Now, the model also incorporates newly developed 24-volt adapter boards to interface to the PLC. And these, of course, ship as part of the assembled training factory and are connected to the PLC via terminals. Now, among other things, the latest generation of adapter boards allows the speed of the encoder motors to be controlled via PWM, also known as pulse width modulation. And they also have push-pull output stages for phototransistors and for buttons. Finally, one of the most important new features. Now, unlike any of the 24-volt models that we've discussed up until now, the new 24-volt Training Factory Industry 4.0 also includes access to a sample program that's available for download. Now, this program is in structured text format and was created based around a Siemens S7 1500 PLC, and it's available for download on GitHub. Of course, not everybody's using a Siemens S7 1500 PLC, so if you want to control it using different PLC models or brands or different types of programming, you can just basically also download the source code from the same GitHub site and make whatever adjustments you need to. Now, as with the first 24-volt models we looked at, the Training Factory Industry 4.0 model does have a relay board for motor polarity reversal, and of course the multi-pin connector, 34 pins with a grid of 2.54 millimeters, along with PCB terminals push-in connections for all the inputs and outputs. And all of the information on this model, as well as much more, is available in a 152-page PDF manual, which can be downloaded from the fischertechnik website, or if you'd like access to that, and this is something you're considering and you'd like to look through that first off, please email me when you see my email address at the end. Email me. I'm happy to get you a copy of this. Now, in the case of the 9-volt version, the control is facilitated through the use of 6 robotics TXT controllers. Now, unlike all the other 9-volt versions that we looked at today, in this case, it's not programmed using the RoboPro coding, which is the proprietary software that fischertechnik created, but instead it's programmed using C, C++. Again, all of the programming is preloaded. So with the 9-volt version, once the connections to the internet and the cloud-based dashboard are made, all of which is clearly outlined in the downloadable documentation PDF, of which there's a separate one for the 9-volt version. And if you want this, email me for that with that as well. Once you've done this, again, you should be able to get started pretty quickly. The 9-volt version will require the addition of 3 120-volt power adapters because of the way that the controllers themselves are connected together. And of course, it goes without saying that either of these models requires that you have the ability to access the internet and that you also have a tablet or other device for accessing the cloud-based dashboard. Dimensions for the models are approximately 39 by 31 by 16 inches, and depending on which version of the model, you're looking at a weight of about 51 to 53 pounds each. Again, with either of these models, we recommend the optional travel and storage case to help protect the model during transport or storage. And that's the Training Factory Industry 4.0 model, which is now available in both, again, the 9-volt and the 24-volt version. Of course, this brings up how much do they cost? So we're going to look at that. If you're looking at something like the vacuum gripper robot, only available in a 24-volt version, it is $1,129.95 list price per unit. The high bay warehouse, which is available in both the 24 and the 9-volt versions, the 24-volt version requires PLC and programming, is $1,369.95. The 9-volt version with the TXT controller and pre-programmed is $1,318.95. Multi-processing station and oven, still available in both 9 and 24-volt versions. The 24-volt version is $1,199.95. The 9-volt is $1,474.95. The sorting line with color detection in the 24-volt version is $1,049.95. The 9-volt version is $1,128.95. The full factory simulation in the 24-volt version is $4,829.95. And the 9-volt version is $5,239. The conveyor belt in the 24-volt version, $324.95. The 9-volt version, which again includes the TXT controller, is $518.95. The punching machine with conveyor belt in the 24-volt version is $419.95. The 9-volt version is $599.95. The 3D or 3-axis robot, the pick and place robot in the 24-volt version is $999.95. And in the 9-volt version with the TXT controller is $1,369.95. Indexed line with 2 machining stations in the 24-volt version is $1,129.95. And in the 9-volt version, $1,395.95. Now, the Training Factory Industry 4.0. In the 24-volt version, again, this comes with the access to the sample program in structured text format. That is $8,999.95. The 9-volt version, which again comes pre-wired to the pre-programmed TXT controllers, programmed using C, C++, is $9,024.95. But there is more. There are new Training Factory Industry 4.0 24-volt models now available. There is the first version, includes the PLC connector. And what this means is basically, as anyone who's working with PLCs and models like this knows, there is a lot of additional wiring that has to occur between a model like this and the PLC connection board, as well as the power source and what have you. This first model that I have up here includes that wiring. It includes the PLC connection board, includes the power supply for that and what have you. That version is $12,079.95. Or if you want the full version already connected to this to a PLC, in this case, it would become connected to a Siemens S7 1500 PLC. So what you're looking at is you're looking at all the wiring, the power supply, the connector board, the PLC connected up, everything good to go. What you were looking at there is for educational purposes. These are available for a cost of $18,499.95. In the commercial version, it is $20,124.95. So essentially, these are, again, the same models that you just saw in the narrated video. The difference being that whether you get that pre-wired aspect to the PLC connection board for $12,079.95, or if you're talking about the complete version with all of the wiring and the PLC itself and the programming, that would be the others. Other items, just because they've been touched on several times, the 120 volt power adapters for the 9-volt models are $12.99 each. And the travel and storage case that we suggest strongly for all factory simulation and training factory industry 4.0 models are $1,524.95 per unit. Do I have any more surprises? Yes, I do. There is a brand new model that is, you may have heard me talk about at the top of the presentation. It's called Quality Control with AI. And the Quality Control with AI system model from fischertechnik is ideal for visualizing this complex subject area in a hands-on manner, as it creates a sustainable learning experience by linking theory and practice. Now, processes can be sped up, fault rates and costs minimized, and fault evaluation standardized. And essentially, the fischertechnik sorting line shown here in this model comes with work pieces in 3 different colors. Now, these work pieces are each marked with 3 different processing characteristics. Let's see if we can get a shot of them. As you see in the trays here, like if you look at the blue tray, it's got certain types of markings. It's going to have a dot in the middle and markings on either side. The white pieces should have only a dot in the middle. There are red pieces that just have markings on the side. So either way, each work piece is marked with what is supposed to be a correct work piece. And there are also various different fault patterns that are included in there. For example, pieces that are mismarked, pieces that have simulated cracks or other types of issues. And what will happen is it works through the conveyor. The work pieces are scanned by the camera on the conveyor and classified with the aid of the trained AI aspect of the model. Now, depending on the color or the feature and the fault pattern, the work pieces are then sorted by the artificial intelligence on the basis of the quality features. The AI used is realized with machine learning and TensorFlow, where an artificial neuronal network was trained with image data. The learned AI is executed on the fischertechnik TXT 4.0 controller, and the model's sequence control is implemented by the RoboPro coding program environment and in Python. Now, if you want to go a step further, you have the option of generating your own AI applications. And in this case, the training is done in Python, for which a suitable example project is provided for explanation. So essentially, this one is only available in a 9-volt version right now. I would like to show you a video of it, but we don't have the video version yet. But it is only available in the 9-volt version right now. You're looking at a cost of $2,089.95 per unit. We will have a 24-volt version coming, and that is expected in fall of this year. So stay tuned on that. And that is, again, that's breaking news. We literally just got one of those shipped to us 2 weeks before the automation conference that I mentioned before that we attended last week. And this model was on display at the conference, and I would have to say that it probably got even more attention than our full-sized training factory model that we had on display. So on that note, if you do have any questions that you would like to ask in real time, this is where you can either use the chat window, which is found on the Zoom toolbar, or the question and answer window. Either of those will work. If for any reason you would prefer not to ask questions now, or you just don't have any, I'm just going to continue on here. You can take the next step. So, for example, if you would like to request one of our full color brochures along with the current pricing, if you'd like to ask any questions directly about anything that we've discussed today that you don't think I've touched on that you'd like to know, anything like that, any aspect of anything Fischer Technic, you can feel free to ask us. If you'd like to request a quote, if you'd like to speak with your dedicated educational representative, or if you'd like to speak with me, either way, you can call us here. Our number at Studica US is 888-561-7521. Our general email address for quotes, requesting information, etc., you can email us at info@studica.com. And again, if you have anything specific that I've again discussed, anything specific Fischer Technic, more of a technical nature, that you'd like me to find answers for, you can email me directly. And that's lance.zurek, lance.zurek @studica.com. So on that note, I'd like to again thank you very much for taking the time to attend today's presentation. You have a great day, and we look forward to hearing from you soon. Take care.